A car is not a single product. A car is the result of thousands of tightly synchronized processes, all happening in the correct order, with tolerances measured in fractions of a millimeter and timing measured in seconds. Every day, thousands of vehicles roll off production lines. But behind this seemingly routine output lies one of the most complex industrial and logistical systems ever created. When we look at a finished car, we see paint, wheels, lights, and an interior. In reality, the car's story began months earlier, long before the first visible part reached the factory floor. By the time physical production starts, everything is already decided. Which steel grades will be used, where each component will come from, when it will arrive, and at which exact second it will be installed. One disruption in this chain can stop an entire factory, costing millions in lost production. If you like similar educational videos, please like, subscribe, and share the video with your friends. The first key thing to understand is this: a car is not built start to finish in one place. It is assembled from components produced in dozens or even hundreds of factories across the world. The engine may come from one country, the transmission from another, electronics from a third, and final assembly from somewhere else. A car manufacturer is less a single factory and more a conductor coordinating a global orchestra. Modern car production is highly automated. Robots stamp metal, weld structures, paint bodies, and move components with precision no human could match. But humans have not disappeared from factories. They are essential where flexibility, judgment, and quality control are required. No two cars on the line are exactly the same. Different engines, trims, colors, software configurations all flow down the same line. There is also a major shift most people underestimate. The more modern the car, the less mechanical and the more digital it becomes. Car manufacturing today is not just about steel and bolts, but about electronics, sensors, wiring harnesses, control units, and millions of lines of software code that must work perfectly from the first start. Before a car ever looks like a car, it must first become a structure. The body is not just an outer shell, it is the backbone of the vehicle. It determines safety, rigidity, handling, noise levels, and long-term durability. If something goes wrong here, it cannot be fixed later. Everything that follows depends on this stage being done perfectly. Modern car bodies are not made from a single material. They are a carefully engineered mix of different steels and lightweight alloys, sometimes combined with aluminum or advanced composites. Ultra-high-strength steels are used where passenger protection is critical. Softer, more ductile steels are used where controlled deformation is needed during a crash. Lighter materials are added where weight reduction matters. Every square centimeter of the body has a specific mechanical purpose. The raw material arrives at the factory in massive coils of metal sheet. Each coil has a precisely defined thickness, chemical composition, and strength. These are not generic materials. Each sheet is designed for a specific part of the car: doors, roof panels, floor sections, pillars, or structural reinforcements. Using the wrong material in the wrong place would compromise safety or durability. These metal sheets then move into the stamping plant. This is where flat metal becomes three-dimensional. Huge presses, often weighing tens of tons, shape the metal using carefully designed dies. It is a sequence of controlled forming steps, where the metal is gradually stretched and bent into its final shape. The goal is to change the geometry without weakening the material or causing microscopic cracks. Every stamping operation is monitored in real time. Sensors measure force, displacement, and material behavior. If the metal stretches too much, it tears. If it stretches too little, the shape will be inaccurate. Any part outside strict tolerances is immediately rejected. A defective stamped panel is not a cosmetic problem. It can prevent proper welding, cause misalignment, or weaken the structure. Once individual panels are stamped, they move to body assembly. Here, dozens or hundreds of separate metal parts are joined together to form a complete body structure. Industrial robots perform thousands of spot welds along with laser welding, riveting, and structural bonding. Modern car bodies rely heavily on adhesives, not as a substitute for welding, but as load-bearing structural elements that increase stiffness and improve crash performance. Precision is everything. The geometry of the body must be exact. Even a few millimeters of deviation can cause doors not to close properly, windows to misalign, or suspension mounting points to shift. For this reason, bodies are continuously measured using laser scanning systems during production. Geometry is verified long before the car ever reaches final assembly. At the end of this stage, the factory produces what is known as the body in white. It is a complete car body without paint, interior, engine, or electronics. It may look unfinished, but structurally it is already the car. Safety performance, stiffness, and basic quality are already locked in. From this point forward, the body cannot be changed, only filled, protected, and equipped. When the bare body leaves the welding area, it may look solid, but in reality, it is extremely vulnerable. Exposed metal would begin to corrode almost immediately. That is why the paint shop is not about appearance first, but about long-term protection and durability. It is also one of the most technologically demanding, expensive, and tightly controlled parts of the entire factory. The first step is not color. It is surface preparation and corrosion protection. The body passes through a series of chemical baths where oils, residues, and microscopic contaminants are removed. Every surface must be perfectly clean. Any remaining impurity would later cause paint defects or corrosion starting points. The most critical stage is electrocoating, often called e-coat. The entire body is submerged in a bath of protective paint while an electric current is applied. This causes the coating to deposit evenly on every metal surface, including deep cavities and closed sections that no spray gun could ever reach. This layer forms the foundation of corrosion protection and is one of the main reasons modern cars can survive decades without rusting. After the e-coat is cured, the body receives sealants and protective materials. These are applied to seams, joints, and welds to prevent water intrusion, reduce vibration, and improve noise insulation. These materials are not cosmetic. They are structural and functional, protecting the body from moisture, road salt, and long-term fatigue. Only now does the visible painting begin. First comes the primer layer, which smooths the surface and ensures consistent color appearance. Next is the base color layer, which defines the actual color of the car. Finally, a clear coat is applied to protect the paint from ultraviolet radiation, chemicals, and mechanical wear, while giving it gloss and depth. Each layer is applied with micrometer-level precision. Too thin, and protection is insufficient. Too thick, and the paint may crack or age poorly. Painting takes place in extremely clean, climate-controlled environments. Temperature, humidity, and airflow are regulated with near-laboratory precision. A single dust particle would be clearly visible on a finished vehicle. Most of the painting is performed by robots to ensure consistency and repeatability. However, humans still play a crucial role in inspection and correction. Paint quality is one of the first things customers notice, and standards here are unforgiving, especially for premium vehicles. After each layer, the body passes through curing ovens where the coatings harden and chemically stabilize. These ovens consume large amounts of energy, making the paint shop one of the biggest environmental challenges in car manufacturing. This is why manufacturers invest heavily in new paint chemistries and lower temperature curing technologies. When the body leaves the paint shop, it finally looks like a finished car. But beneath the surface, it is still empty. There is no engine, no interior, no electronics. What it has gained is identity, protection, and long-term resistance to the environment. Once the painted body leaves the paint shop, it enters the stage where it finally becomes more than a shell. This is the final assembly line, the place where thousands of components produced all over the world come together in a precisely timed sequence. Here, speed matters, but precision matters even more. One mistake can stop the entire line. Assembly is not random or flexible. Every station has a strict time window, often measured in seconds. The car moves continuously, and each team or robot must complete its task before the body advances to the next position. This is why modern factories rely heavily on just-in-time logistics. Parts arrive at the line exactly when needed, not earlier and not later. Warehousing is minimized because delays and excess inventory both cost money. One of the earliest and most complex tasks is the installation of the wiring harness. Modern cars contain kilometers of cables, dozens of control units, sensors, and connectors. The wiring must be routed through narrow channels, secured precisely and kept away from heat, vibration, and moving parts. Despite advanced automation, this step still relies heavily on human workers because flexibility and spatial awareness are critical. At the same time, systems that will later be inaccessible are installed. Brake lines, fuel lines, climate control components, and fluid systems are mounted while the body is still open. Every fastener has a defined torque value, which is digitally monitored and recorded. If a bolt is tightened incorrectly, the system flags it immediately, and the car cannot proceed without correction. One of the most important moments in car manufacturing is known as the marriage. This is when the body is joined with the drivetrain. The engine, transmission, suspension, axles, exhaust system, and often the steering system are pre-assembled into a single module. At a precisely synchronized moment, this module is lifted and bolted to the body from below. Within minutes, the car is standing on its own wheels for the first time. Next comes the interior installation. The dashboard, seats, airbags, seat belts, door panels, screens, and controls are installed in a strict order. The interior is not just about comfort or appearance. It is a critical safety zone. Airbags, seat structures, and restraint systems must work together during a crash, which means tolerances are extremely tight. At the same time, the car receives its software. Modern vehicles contain dozens of electronic control units that must be activated, programmed, and synchronized. The car is powered up digitally for the first time. Systems begin communicating, sensors initialize, and the vehicle's electronic identity is created. Without this step, the car would be nothing more than a mechanical object with no intelligence. By the end of the assembly line, the car looks complete. It can start, move, steer, and brake. But appearance and basic function are not enough. Before the car is allowed to leave the factory, it must prove that everything works exactly as intended. When a car reaches the end of the assembly line, it may look finished, but from the manufacturer's perspective, it is still not approved. This final stage exists for one reason only: to decide whether the vehicle is allowed to leave the factory or must be corrected, reworked, or in some cases rejected entirely. There are no shortcuts here. The process begins with electronic diagnostics. The car is connected to testing systems that communicate with every control unit. Engine management, transmission, braking systems, driver assistance features, safety systems, sensors, and software are all checked simultaneously. Each system must respond within precise parameters. A single fault code is enough to stop the car from progressing. Next come mechanical and functional tests. The vehicle is placed on roller dynamometers that simulate real driving conditions. Acceleration, braking, steering input, traction control, and stability systems are tested under load. Wheel alignment, suspension geometry, vibration levels, and noise are measured. Braking systems are tested repeatedly to ensure consistent performance. One of the most critical steps is the water tightness test. The car enters a sealed chamber where it is sprayed with high-pressure water from all directions. This simulates heavy rain, car washes, and years of exposure to the elements. Inspectors check for even the smallest trace of moisture inside the cabin, trunk, or electronic compartments. Any leak is unacceptable. After technical testing comes visual inspection, performed by trained human inspectors. Paint quality, panel gaps, surface finish, interior materials, trim alignment, and small details are examined closely. Human eyes are still better than machines at detecting subtle imperfections. This step is especially strict for premium and luxury vehicles. Some cars also undergo a short road test. This is not a full drive, but a controlled evaluation designed to detect abnormal sounds, vibrations, steering behavior, or drivetrain irregularities. Even minor anomalies can trigger further inspection or rework. It is important to understand this clearly. Not every car that reaches this stage leaves the factory. Some vehicles are sent back for corrections. Others are partially disassembled and repaired. In rare cases, a car may be removed from the production flow entirely if it fails to meet required standards. This is the cost of maintaining quality and brand reputation. Once a car passes all tests, it receives final approval. It is registered in the production system, labeled for logistics, and prepared for transport. From here it moves to storage areas, trains, trucks, or ships, beginning its journey to dealerships and eventually to customers. And with that, the process is complete. Car manufacturing is not simply about assembling parts. It is a highly coordinated industrial ecosystem, combining materials, science, chemistry, robotics, software, logistics, and human judgment. Every car represents thousands of precise decisions that had to be executed flawlessly. The car you see on the road is not ordinary. It is one of the most complex products ever manufactured at mass scale.